Good morning, students. So today we are going to discuss about the free body diagram. So what is free body diagram? So when there are more than more than one body in the system, then to analyze the system, each body is considered separately along with the forces acting on the body. So the diagram showing the forces on individual body is called the free body diagram. So that means first we have to pick up the body, so then we have to calculate how much forces are acting on the body. Okay, so this diagram showing the all the forces acting on the body is called the free body diagram. So there are three steps to calculate the free body diagram. The first step is identify the body or the system which is analyzed. Okay, so we'll take one each body one by one. Then choose the coordinate axis as per the convenience. Now remember, we'll choose the coordinate axis such a way that most of the forces should lie on the axis. Okay, most of the forces should lie. Suppose there are, okay, suppose you have a body of mass m, that two forces, okay, three forces are acting. Okay, so force 1, force 2 and force 3. So we'll take the coordinate axis as the normal way. So x axis or y axis, then all the forces will lie in the on the axis. But if your box is in this way, okay, and force are acting like this, f and f. Okay, now we'll choose the coordinate axis such a way with a tilted angle. Okay, so that all the forces should lie in the all the forces or minimum most of the forces should lie in the axis. So the third point is represent all the forces acting on the body by vectors. Okay, so let's see. So first thing is, so a block of mass n is lying on a table. So we have to calculate this how much forces are acting on this block of mass m. So here the gravity is attracting this block of mass m with the force mg, correct? So these forces are acting on this block. Now since gravity is attracting this block, so as a result, what is happening, this block is also pushing the table. Okay, this block is also pushing the table. This force is called normal reaction force. Normal reaction means a perpendicular force. So this block is actually pushing the table downward direction, since gravity is attracting, gravity is pulling it. But look, this n force is not acting on the block, this force is acting on the table, so we will not calculate this n. But as a reaction, the block is also, this table is also applying a force on the block. So this force is also a normal reaction force. Normal means perpendicular. Now this n and n, these two are normal, these two uh, are called action reaction pairs. Okay, this n and n, these are action reaction pairs. Okay, so how many forces are acting? The two forces are acting. The mg force, the gravity is attracting with mg. The n normal force n, the block is pushing the this table is pushing the block with normal force n. Okay, so there are two forces. Now look one thing carefully, that the block is not moving. Now according to the Newton's second law, if an object is at rest condition, that means the net force acting on that object is how much? 0. So net force is 0. So from here net force is 0, so you can write n. Now this n and mg, they are in opposite direction. So if you take n as positive, then you have to take mg as negative, or if you take mg as positive, then you have to take n as negative. So if you take n as positive, then mg will negative, so n minus mg is 0, so n is equals to mg, or you can directly write n is equals to mg because they are in opposite directions. Okay, so let us take another example. So here we'll calculate how many forces are acting on this block, on the table, okay, and the earth also. Now remember one thing, that this n and mg, they are not actually action reaction pairs. They are not action reaction. These two forces are equal and opposite, that is correct, but they are not action reaction pairs. I'll tell you in this picture. Look, so how many forces are acting on the block? Two forces, normal reaction and mg. Now how many forces are acting on the table? Now first, gravity is attracting this table with mg force. correct. Okay, and now since this block is now this block is pushing this table with normal reaction force n. Now this n and this n, these are these two are actually the action reaction pairs. This n and this n, these are actually action pair. Okay, so this m, actually the block is pushing, since gravity is attracting the block is pushing the table in downward direction, so this n is coming from there. And this n, now since the block is pushing the table, now as a reaction this table is also pushing the block in upward direction, so this is then the second normal reaction. These two are actually action reaction pairs, correct. So two forces we have discovered, two forces, mg, the gravity is attracting the table with mg force, and normal reaction force, this the block is applying on the table in downward direction. Now look at the two stands of the table. Now the two stands of the table, they are connected with the ground. Now these two stand, now since gravity is attracting the table, these two stands are actually pushing the ground in downward direction, okay, with forces n1 and n2, correct. Now since this stand is applying a force on the ground, n1 force, the ground is also applying n1 force, normal reaction 1 n1 force on this stand of the table. And this stand is also facing n2 force, normal reaction force, so this force is applied by the ground on the second stand of the table, okay. So there are total, we can see there are total four forces acting on this table, n1, n, mg and n2, correct. So from here you can write that n plus mg is equals to n1 plus n2, correct. And this table is, these two forces are these two forces are equal, n plus mg is equals to n1 and n2. Why? Because the block is neither going downward nor going upward, so it is at rest position, that means net force is 0. So you can write that n plus mg is equals to n1 plus m2. Now we'll see how many forces are acting on the earth. Look, since this gravity, this earth is attracting this block with mg force, this block is also attracting the earth with mg force. These two mg are actually action reaction pairs. And again, since the earth is attracting the table with mg force, the table is also attracting the earth with mg force. These two are action reaction pairs, remember, these two are action reaction pairs. And here n1 and n1 these two are action reaction pairs, and n2 and n2 these two are action reaction pairs, okay. But all the action reaction pairs, so remember, every force lies in pair, also lies in pair, but you can clearly see all the action reaction pairs, they are not applying on the same body. The action reaction pairs, they are applied on the different body. Here mg is applied on the block, but this mg is applied on the earth. This n1 is applied on the surface, and this m2 is this n2 is applying on the ground, and this n2 is applying on the table. So these action reaction pairs, they are applied on the different objects. Okay, now focus on which forces we have included. Okay, so here block mg, we have only included this mg force, which is applied on the block of mass m. This second mg, which is applied by the block on earth, we did not include this, we did not included this, because this force is acting on the earth. So when we calculate the what force is acting on the earth, then we will calculate this mg, okay. So this is the reaction force. We have calculated only the action force. Now okay, so I have already explained that this normal reaction in now. Okay, finally this m and mg, they are not action reaction pairs. So why? Because I already explained, because the mg is attracted by, mg is the force applied by the earth on the block, but there is another mg which is applied on the earth by this block, and that force applied on the earth, so we did not include here. Okay, so that's why we did not include here. So this is a normal reaction force, this is the force applied by the table on the block. There is another normal reaction which is applied by the block on the table, okay, but that force is acting on the table, so that's why we did not include it here. Okay, and this M and Mg, they are not action pairs. Now this is another important point. Here two blocks are lying after one after another, okay. So here we have to calculate how many forces are acting on the here, acting on this body. So obviously gravity is attracting this m1 with mg force, okay. Now so since gravity is attracting this mg, this m1 is pushing the m2 with n1 force, so as a reaction this m2 is pushing the m1 with n1 force. So there are two forces are acting on the m1, n1 and mg. So we can clearly write first n1 is equals to mg. Why? Because these two, m1 is at equilibrium, so that means these two forces are in equilibrium. So n1 and is equals to mg. Because now how many forces are acting on the m2? This block, m1 block, is applying a force on m2 with applying a n1 force on m2, okay. The gravity is also attracting this m2 with m2g, correct, okay. Now there is another force, okay. That force is the ground is pushing the m2 with a n force, normal reaction n force. We say we can even take n3 also. So the block is the actual ground. This m2 block is actually pushing the ground. But this ground is also pushing the m2 block. So block is applying force, normal force n. So there are three forces are acting: m2g, n, and n1 in the downward direction. So you can write that n is equals to n1 plus m2g. Why n1 plus m2g? Because these two forces are in the same direction and n is the other direction. So that's why we write n is equals to n1 plus m2g. Okay. Now if block is moving, then this equation will not work. This equation it will work when the block is in equilibrium. Now if you take these two system, this block, this m1, if you assume that this m1 m2 are in the same are the same system, then we have to calculate how many forces are acting. So gravity is attracting with how much force now? m1 plus mt. If you consider this m1 plus m2 are in the same system, so then total mass is m1 plus m2. So gravity is attracting with m1 plus m2g force. Now since gravity is attracting this m1 and m2, so this system actually pushing the ground. So as a reaction, the gravity, the ground is applying a normal force n. So from here is equal, right? N is equals to m1 plus m2g. m1 plus m2g. Okay. So this is the, so in this way you have to draw the free body diagrams. So we'll imagine blocks. Now what is the system? Okay, so here the picture, in this picture you have earth, this a monkey, a boy, and a horse. Okay, so we can take this only earth as our system, or we can take the earth and the monkey as our system, or you can take the boy and the earth our system, or you can take all the fours as our system. So we'll take the system means a body or combination of bodies which are being observed. Okay, so we can take any of these four combination as our system according to our convenience. Okay, so we can take this man, monkey, and the earth as a system, or you can take this man and monkey as our system only. Okay, so we'll take as our convenience. So system is a body or combination of bodies which are being observed. Okay, so we can take only one or two or a combination of four or as our system. Now this is the picture of pulley system. So you have two masses m1 and m2. Okay, so here we can take this only M2 as our system, or as only M1 and this M1 as our system, or we can take all these both the M1 and M2 as our system. Okay, so that means we can take anything as our convenience. That it is only matter of choice. What is actually is to be observed becomes our system. Okay, the classification of force, there are two kinds of force, one is internal force, other is external force. Okay, so internal external force means, if the force acting on the body or particle is applied by some other body which is excluded in the system, therefore such force is termed as internal force. Okay, so that means if we take only, if we assume that all these four boys is our system, then this other boy, it is a external system. But if, remember, if you take all the five as our system, then there is no external force, remember. And if you take this boy, the lone boy, as our system, then these four boys will be our external force, and this boy will be our internal force. So it depends on the system. Okay, if you take these four boys, so these four boys are our internal force, but this alone boy, he is our external force. External force is the force acting on the body particle is applied by some other body which is not part of the system, or and acts as an external agent. Okay, so Ram and Sam system, if you take Ram as our system, then Sam is our external system and Ram is our internal system. If you take Sam as our system, then Sam is our internal system, Ram is our external system. So if you take both as our system, then both Ram and Sam will be our internal system. There is nothing in the external system. Okay, so in this way. Now in the previous cases we have drawn the free body diagram of a balanced system. Okay, where the net force was 0. Now if the force is unbalanced, okay, so if the body starts moving, then what will be our free body? Now in that case we'll discuss the free body diagram here. Now here a body of this block is at rest initially. Now we have applied a force F. Now if we apply force F, obviously the body, it will start moving in the right side because we applied a force in the right side. So body will move in the right side means it will have some acceleration. Okay, A. So let's draw the free body diagram. Gravity is attracting it mg, and there is normal reaction force N. It is written in R here, so it is N in the upward direction. N is the normal reaction force applied by the ground on this block of mass M. So from here you can write N is equals to mg. Okay, these two forces are equal and opposite. Okay, they are balanced force. But here in the right side you have unbalanced force F is equals to how much? Now due to this force the body will start moving, that means it will have some acceleration. From Newton's law you know that force is equals to mass into acceleration. So you can write F is equals to ma. So there will be two equations, F is equals to ma and N is equals to mg. Correct? Okay, F equals to ma. From here you can write A is equals to F by A. Now here force inclined at some angle in pulling. You are pulling this. So here you have a block of mass M, and you are pulling this block of mass M with an angle theta. Okay, you are pulling in this direction. So first what you have to do, we have to break this force into two components. Okay, into its two components. So this will be our cos theta. This will be our f cos theta and this will be our f sin theta. Correct? Because this is theta our. Okay. Now we'll take our axis. So this is our axis. So f cos theta is here. Here is n normal reaction and f sin theta. And gravity is acting in which direction? Mg downward direction. From here you can write that n plus e sin theta. N plus f sin theta is equals to mg. N plus f sin theta So here you have n not r plus f sin theta is equals to mg, because n and f sin theta they are in same direction, mg is other direction. But here on right side only you have only one force. Now now forget this f, because we have already take the component form of it. So f cos theta, in right side you have only one force, f cos theta. So due to this f cos theta, the body will move in the right side with a acceleration. Okay, so you can write f cos theta is equals to m into a, mass into acceleration. Okay, so here, or here you can write a is equals to, so this derivation you don't need this derivation. Okay, so geo just remember how can we derive, how can you derive the free body diagrams. Okay, so we'll solve the numericals in the next class. The second case is very similar to for the first one. The equation is also same, so you'll do this one on your own. So here, so a block of the system, it is, the block is actually lying at an inclined plane. Okay, so it is lying in an inclined plane. So gravity is attracting, gravity always works downward direction. Okay, perpendicularly downward. So gravity is attracting in downward direction, and so but it is pushing the table. Okay, so this block is actually pushing the table in this direction. Okay, normal reaction. As a reaction, this inclined plane is also pushing this block in this direction. This is normal reaction. Okay, and so there are only two forces, mg and r. These two forces are acting on the table now, acting on this block. Now we will break this mg component into two parts. Okay, this is mg cos theta and this mg sin theta. Why we are breaking? Because so that all the forces, then this mg, we can remove this mg, then we will take mg cos theta, mg sin theta. Now here our axis will be, will take axis in this way at an angle theta. This is our now axis, because if you take our axis in this way, then all the forces mg sin theta, mg cos theta are these three forces, they will lie in this axis. Okay, so we will take this axis in this way. So from here you can write that r, the r force is in the upper side, mg cos theta in the lower side. You can write that r is equals to mg cos theta. Now mg sin theta in the opposite direction, you don't have any force. Okay, that means it is an unbalanced force, and due to this unbalanced force, this block will starts moving in this direction. That means it will have some acceleration a. So you can write that mg sin theta is equals to ma, because force is equals to ma. Here force is equals to mg sin alpha. Sorry, not theta alpha here. So mg sin alpha is equals to ma, or a is equals to g sin theta. So in this way you have to draw the free body diagrams. So thank you for today.